welcome to International Visiting Lecturer webinar hosted by STEKOM University. And also welcome to our distinguished speaker, Ms. Kateryna Yalova. This webinar is being conducted live via Zoom, recorded and broadcasted simultaneously on YouTube. So we warmly welcome participants joining us from different countries and time zone. We are truly honored to be your presence today and sincerely appreciate your participation in this international academic forum. Before we begin our main session, we would like to express our gratitude to all institution speakers and organizing committees, members who have made this event possible. Today's webinar is part of commitment to strengthening international collaboration, promoting sustainable development, and advancing engineering education in global context. Now we proceed to our International Visiting Lecturer Day 1 with the theme Advancing Engineering Education through International Collaboration and Sustainability. This session will be explore innovative approaches in engineering education, the importance of global academic partnership, and sustainable practices in today's rapidly evolving technological landscape. Our speaker is Ms. Kateryna Yalova, the head of Department of System Software. She has extensive experience and expertise in the field of system software and engineering education, and we are confident that her insight will be highly valuable and inspiring for all of us. Ladies and gentlemen, please join me welcoming Ms. Kateryna Yalova. The floor is yours.
Okay. Thank you. First of all, we are pleased with the cooperation initiated between our university and hope for fruitful collaboration in the future. And today we would like to begin by presenting our university and the Department of Software System, which I had. And let me share my presentation. Okay. So could you please tell me, can you see my presentation now?
Yes, we can clear it. We can see it clearer.
Okay, thank you. So first of all, I would like to present our university and the department. And also we will talk about advancing engineer education through international collaboration and sustainability, but within the context of modern IT education. And first of all, I would like to present our state. Ukraine is an independent country located in the southeastern part of Europe with a rich history and culture. And Ukraine is an industrial and agricultural country with strong energy, metallurgy, and an advanced IT sector. Our university is located in the city of Kamensky. It's a large city in the Dnipropetrovsky region of Ukraine, situated on the Dnipro River. The economy of Kamensky is based on a strong industrial complex with metallurgy and the chemical industry playing a key role. Our university, Dniprovsky State Technical University, is a leading higher educational institution with a rich history and strong academic and scientific potential. In 2025, the university celebrated the 105th anniversary of its founding. The university employs 110 academic staff members who ensure the core educational process, including 25 doctors of sciences and 93 doctors of philosophy. The distribution by academic positions is shown on this slide. The university provides education at 3 qualification levels: bachelor's, master's, and doctor of philosophy programs. Currently, a total of 2,211 students are enrolled at the university. The infographic showing the distribution of students by educational levels can be seen on the screen. The mission of our university is to carry out educational activities at a level that ensures the training of a highly educated, intellectual elite of society to meet labor market needs through the development and dissemination of advanced educational models and technologies. To fulfill the university mission, education is provided through 59 educational and professional programs, the quantitative distribution of which by qualification levels is shown on the slide. The university comprises 4 faculties, namely Faculty of Metallurgy, the Faculty of Mechanical Engineering and Transport Technology, the Faculty of Computer Technologies and Energy, and the Faculty of Economics and Social Communication. On the screen, you can see the structure and names of the departments of each faculty. In addition to the faculty, the university includes 3 separate structural units: the Technological Vocational College, the Technological Economic Vocational College, and the Vocational College of Food Technology and Entrepreneurship. On the screen, you can see the structure and names of the departments of each college. The university infrastructure includes 5 academic buildings, 3 dormitories, 3 sports halls, 6 sports grounds, 2 football fields, library, dining facilities, sports and recreation camps on the Oil River, the student club Flaming Stars, the University History Museum, and a medical center. On this slide, you can see a photo gallery of the university's infrastructure components. Over the past 3 years, university has signed more than 20 memoranda and cooperation agreements with higher educational institutions in Poland, Croatia, Serbia, Bosnia and Herzegovina, the Czech Republic, and Indonesia, thanks to which international internship conferences and research projects are conducted. The university operates over 100 laboratories where students and researchers conduct their studies and carry out contract-based research projects. On this slide, you can see some photos of the laboratories of the Department of Metallurgy, Department of Conductive Matter Physics, Department of Electronic and Electronic Communications, and the laboratories of the Department of Electrical Engineering and Electromechanics. Currently, the Department of Software System is a part of the Faculty of Computer Engineering and Energy. This department was established in 1993. The academic staff of the department teaches students in the software engineering program, conducting classes in computer laboratories. Education in the software engineering program is offered at the bachelor's and master's levels, and graduates also have the opportunity to continue their studies in the PhD program in applied mathematics. This slide shows the duration of study for different qualification levels and modes of education. Bachelor's program lasts 4 years, master's program lasts 1 year and 4 months, and doctoral PhD programs last 4 years. For student training, we use the software engineering body of knowledge standard, an international document created to integrate knowledge in software engineering developed by the Institute of Electrical and Electronics Engineering. A list of some of the mandatory professional courses is shown on this slide, including requirements analysis, software modeling and analysis, algorithm and data structures, databases, computer network organization, and others. The student learning process is regulated hierarchically at the national, university, and departmental levels. Student training is carried out based on the requirements, criteria, and provisions of the state standard for the software engineer specialty, as well as the corresponding bachelor's and master's educational and professional programs corresponding with this standard. A detailed regulation of the educational process, taking into account the academic calendar, is reflected in the curricula for each year of study. For each course, a syllabus and a set of instructional and methodological materials are developed, containing both theoretical and practical training resources. The integral competency of graduates in the software engineering is the ability to solve complex specialized tasks or practical problems in software engineering characterized by complexity and uncertainty of conditions using theories and methods of information technology. The main learning outcomes for students among the 28 determined are knowledge of an ability to apply methods for algorithm development, software construction, and the design of data and knowledge data structures. Practical application of software tools for data domain analysis, design, testing, visualization, measurement, and documentation of software. Ability to make informed choices of programming languages and development technologies for solving tasks related to software creation and maintenance. This slide illustrates the overall structure and component of the educational and professional programs at the bachelor's and master's level. You can see that the bachelor's program comprises 240 credits and the master's program comprises 90 credits. Also, you can see that the educational professional programs are divided into two parts, the mandatory parts with the mandatory components and also with the elective components. Also, you can see the distribution of these components on the slide. The main areas of student training cover a wide range of professional fields. Our students are prepared in enterprise resource planning systems development, web application development, mobile application development, game application development, Internet of Things and cloud application development, and intelligent systems and artificial intelligence application development. Also, you can see on the screen some tools and informational technology that we are using in our study. On this slide, you can see the examples of the students' project in the field in the field of enterprise resource planning systems development. The student develops skills in analyzing business domains, designing databases, implementing software, testing information system for financial management, sales and supply management, human resources, accounting and auditing management as well. On the screen, you can see several examples of user interface forms developed as the part of student projects for information systems in an agricultural enterprise, a blood transfusion center, and environmental safety systems. In the field of web application development, students acquire skills in developing modern web applications with a focus on creating dynamic and interactive internet-based solutions, including a full-stack front-end and back-end development. On the screen, you can see several examples of user interface forms developed as part of student projects for the web applications, including a school information website, an information and search system for a real estate agency, a cafe website, and an online bulletin board. During their studies in mobile application development, students acquire the following key skills: designing and implementing mobile applications for the Android operating system, designing user interfaces and ensuring a user-friendly experience, working with local databases and the file system, testing, debugging, and optimizing mobile applications. On the screen, you can see examples of user interface screens developed for mobile applications, such as a pharmacy search app, a taxi service, a personal task planner, and an audit layer. During their studies in game application development, students acquire the following skills: designing and developing two-dimensional and three-dimensional games using modern game engines, programming game logic, mechanics, and real-time object interactions, applying physical models and simulations, and working with sound and visual effects. Also on the screen, you can see some examples from the student project. During studies in programming cloud applications and Internet of Things applications, our students gain knowledge in developing applications and services for cloud data storage and processing, working with sensors, actuators, and peripheral devices of Arduino, processing and visualizing data received from IoT devices, integrated software solutions with mobile and web applications for remote control. On the screen, you can see examples of cross-platform student projects that consist of a web application and software code for implementing the hardware component on the Arduino platform. Graduates of the department received bilingual European-style diplomas, along with supplements containing detailed information about the general and professional competencies acquired, learning outcomes achieved, and grades obtained. Contemporary IT education faces several global challenges caused by the rapid evolution of technologies and changing labor market demands. Educational programs often lag behind the IT industry, leading to the obsolescence of knowledge and growing gap between academic training and practical skills, which reinforces the shift towards skill-based hiring. The widespread use of generative artificial intelligence has significantly transformed learning processes, but has also contributed to a decline in algorithmic thinking, the erosion of fundamental engineering skills, and a crisis in traditional knowledge assessment methods. In parallel, the educational system experiences a shortage of qualified instructors with industry experience, limiting the timely renewal of competencies and the adoption of emerging technology. At the same time, IT education is shifting from manual coding toward system-level thinking, increasing the demand of systems engineering and solution architectures, while soft skills such as communication, critical thinking, and teamwork remain insufficiently integrated into technical curricula. As for Ukrainian IT study and IT education, since the full-scale armed invasion of Ukraine by the Russian Federation in 2022, the Ukrainian education system has faced profound challenges. Educational losses have accumulated due to lost instructional time, decreased student and teacher motivation, and growing disparities in educational quality. Infrastructure and safety issues have arisen from the physical destruction of schools buildings, the need to conduct lessons in shelters, the frequent blackouts, electricity rationing, and internet disruptions. A human capital crisis has emerged, characterized by internal and external migration, workforce shortages, and financial pressures on educational institutions. These conditions have also led to widespread psychological exhaustion, including cognitive fatigue, chronic stress, and reduced opportunities for socialization, among students and educators. To ensure a high level of student training amid global and national educational challenges, the department's development strategy includes the implementation of activities related to collaboration with internal and external stakeholders, development of material and technical infrastructure, ensuring high-quality education, productive scientific activity, and mobility of academic staff and students. Cooperation with stakeholders, entities interested in the outcomes of the university's activities that influence the educational process or are affected by its result, as well as with employers, is carried out through the review of educational programs, guest lectures, and educational field visits. This cooperation helps align graduate competencies with current labor market needs and requirements. Also, the primary focus of student training is software design and development. The development of the department's infrastructure and material technical base is not limited to the acquisition of computer equipment. It also involves the creation of a laboratory environment for practice-oriented learning, enabling students to acquire real practical skills in the field of information technology. In particular, a postgraduate student of our department developed and implemented a three-dimensional printing setup along with a web application that provides remote monitoring and control of the printing process via web API. The implementation of this project is directly integrated into the educational process, especially within the course Computer Graphics, where students have the opportunity to create three-dimensional model prototypes and produce them using 3D printing. Within the course, professional practice in software engineering, students had the opportunity to practically test developed software solution for drone control and the application of computer vision method. Also on the screen, you can see a short video from the session, which included in this slide. At the end of 2025, a grant application was submitted to the International Kronos Fund Foundation for the creation and integration in our educational process of an artificial intelligence and Internet of Things laboratory, which will facilitate laboratory exercises for the relevant course. Since 2023, the university has been a member of Cisco Networking Academy, a global educational program in the field of information technology and cybersecurity developed by Cisco Systems. The program operates as a large-scale online platform with a network of partner educational institutions and is designed to provide up-to-date, practical-oriented knowledge in the IT domain. Cisco Network Academy offers a wide range of courses covering the following key areas: networking technologies, cyber security, programming and operating systems, the Internet of Things, and data analytics. The advantages of Cisco Network academic courses include their relevance and modernity, access to Cisco industry certification, integrated development and co-testing environments, multimedia support, and a virtual laboratory environment for computer networking. On the screen, you can see some of the forms from the Cisco Networking Academy system that are used in our IT education. We integrate Cisco Networking Academy courses into our educational programs, using them as an effective tool to ensure high-quality student learning. The course content can be supplemented with custom instructional materials and individual assignments in various formats, allowing flexible adaptation of the learning process to the objectives of a specific discipline. Additionally, the platform includes built-in tools for automatic tracking and assessment of learning outcomes, as well as a mechanism for remote interaction with students. Thanks to these features, Networking Academy can be used as a full-fledged learning management system. On the screen, you can see also how Networking Academy course content is applied in our academic courses. Upon completing a course, students receive also the corresponding certificates, examples of which are shown on the slide. The implementation of practical-oriented learning, the question of the effectiveness of blended or distance learning formats become particularly acute, especially in disciplines that develop algorithmic and abstract thinking. Aware of these challenges, instructors apply effective pedagogical approaches and learning support tools. In 2025, in collaboration with master's students and faculty, a virtual programming laboratory was designed and programmatically implemented, which was tested within the course algorithm and data structure. The main feature of the laboratory, in addition to the integration of multimedia content and the presence of a built-in code emulator, is an adaptive model based on reinforcement machine learning methods, which allow the content to be adjusted according to the user's actions and preferences. Also, on the screen, you can see several interface forms and a short video demonstrated an animation to facilitate a clearer understanding of the algorithm concept. The academic staff provide also the scientific and research activities. The department academic staff are carried out the scientific and research activities through the implementation of research projects, the publication of scientific articles and monographs, and participation in scientific conferences. The most significant achievements include participation in the international project, namely International Research Network for the Analysis and Development of New Tools and Methods of Progressive Pedagogical Science in the field of ICT, e-learning, and intercultural communication. And the next one, named Knowledge Transfer Sector, from the exchange of the engineer innovations to the development of interdisciplinary curricula. Within the framework of this project, research and educational visits were conducted to Slovakia, Austria, Sweden, and Spain. The research outcomes are published by the department's academic staff in two our university peer-reviewed scientific journals, as well as in leading international publications indexed in Scopus and Web of Science. In addition, faculty members regularly participate in international scientific conferences, presenting their research ideas and findings. You can see several certificates of participation in international conferences on the screen. The department's academic staff motivate and supervise students in their research activities. The most recent international scientific conferences in which our students participated include the conferences Advanced Computer Information Technologies in Croatia and Theoretical and Practical Aspects of Distance Learning in Poland. You can also see the certificates from these conferences on the screen. The implementation of student academic mobility is carried out in the following areas. Credit mobility, which involves temporary study at other higher educational institutions in particular within Erasmus programs. Currently, partner institutions are being sought for participation in Erasmus programs in 2027. In addition, students regularly participate in webinars organized by the International Academy of Education and Training of Germany, focused on the conditions of IT internship in their country. The next one, educational and industrial internship, within which bachelor students completed educational internships at the Series Academy in Barcelona, Spain. Students also submit applications to participate in the Cisco Incubator Program Technical Online Internship. And the last one, the short-term academic mobility, which is implemented through regular participation in intensives, trainings, and workshops organized by leading universities and IT companies, including EPM and Cisco and Google company. In addition, students took part in the educational and cultural project European Integration, within which they visited educational institutions in Poland and undertook educational and cultural study trips to Germany, France, and Czech Republic. In addition, students annually participate in programming Olympiads and competitions. They consistently demonstrate strong performance in the international college programming contest. The world's most prestigious international team-based algorithmic programming competition for higher educational students. The contest includes regional, national, and world finals and serves as an important platform for students' professional development and integration into the international IT community. As a conclusion, engineering and IT education development requires international collaboration, innovation, and sustainable educational strategies. Alignment with international standards and industry platforms ensure the relevance of graduates' competencies. Practice-oriented learning, integration of modern technology, and stakeholder engagement bridge the gap between academia and industry. Despite global challenges and wartime conditions, Ukrainian universities maintain educational quality through innovation and international partnerships. Academic mobility, joint research, and student participation in international projects strengthen global integration and long-term sustainability of engineering education. Thank you for your attention. We are open to cooperation. And from my side, this is all.
Thank you very much, Ms. Kateryna Yalova, for the insightful and inspiring presentation. We move now to the question and answer session. For all the participants, you are welcome to submit a question through the Zoom chat. And now we already have a couple of questions. Maybe we can start one by one to answering.
Yes, I will try to find the chart.
The first question is from Helena. Do you able to see the question, Miss?
Yeah. How do you define the role of international cooperation in advancing engineering education in today's global context? As was presented in my presentation, we are sure that international collaboration can be implemented in different ways, including international research projects, international students mobility, and also staff mobility. Also, we think that it is possible to take participation in different international projects using also such support as grant work and grant project.
I hope the answer is satisfy Helena. If you have any more question, you can ask again in the live chat.
Yes.
We can
How can
yes.
I will read it.
Yeah.
How can interdisciplinary approaches enhance engineer education for sustainability? Yes, thank you. This question is really a great question because the interdisciplinary approaches, along with the practical oriented approach, is the great possibility to enhance engineering education. And also in our educational program, we have implementation of such approach. And we try to create such an interdisciplinary approach because IT education is related not only to the IT sector, but also it is used to create program in different sphere of our life. So we try to to give our students a lot knowledge about different areas. And also we have a special block of discipline, like a cycle of environmental discipline that learn our students how to live in our modern society. So it is, as a conclusion, the interdisciplinary approach is a very powerful mechanism to enhance engineering education.
It's powerful and impactful.
Yes.
Okay, the next question is how can student contest be designed to promote sustainable and environmentally responsible engineering solution?
Student contacts. I think that first of all, the international contents for students, it is a way to interact between different culture, between different students, and it can be used to develop the intercultural competences. First of all, and also this international context can be provided under the slogan about environmentally responsible engineering solution to encourage students to create some project, maybe from green IT solution to make our environmental responsibility more responsible, if I can say so. So I think that the contents can be a platform to share such ideas.
Okay, thank you very much for your answer, Miss Kateryna. As we conclude this intellectually simulating virtual lecture series, I think Miss Kateryna is already been closed with the session. My profound appreciation is directed to our distinguished guests right now, today, and your deep insight and generous knowledge sharing have enriched our intellectual discourage. We stand genuinely privileged to have had you grace us with your expertise. Farewell, and I think it's enough for today's webinar. Thank you very much for Miss Kateryna. I hope we can participate more in the next project.
Yes, thank you also from our part. We are glad to be present here. Thank you.
Yeah. Before we close today's session, we can connect it to the next day for next day to visiting lecturer with the the next guest speaker. Today we can picture together, take a picture together
Yes.
via Zoom. May all of the participants can open their cam, and we start with counting with 1, 2, 3. Different pose. 1, 2, 3. Thank you very much, Miss Katrina. I hope you soon with the best wishes, and have a good day.
Thank you.